Welcome back. So far, we have learned how to create a Hadoop cluster in the cloud using Amazon Web Services. We also learned how to connect to the cluster using Secure Shell Protocol. We also learned how to move files back and forth from our computer to the cluster so the files are there and ready for data processing. So we are ready to start big data processing. We're going to start with MapReduce. MapReduce is one of the core processing engines in Hadoop. There are several reasons we want to learn about MapReduce, especially from the learning perspective. Although MapReduce is not very popular recently, it's replaced with Spark, which we'll see later in our data analysis. There are still organizations out there who have MapReduce jobs and process MapReduce jobs, so it's good for us to know how to run a MapReduce job. And if it's a job out there that we want to modify, we should know some basic skills how to create a MapReduce job and process the data. Also, MapReduce illustrates the concept of distributed processing. We have mappers and the reducer, which basically demonstrates the concept that data does not move to the processing engine. We send processing tasks where the data is. This way we can increase the efficiency and reduce the network traffic. The concept of MapReduce is relatively simple and old. Here is how a recent source describes the MapReduce. Think of map and reduce tasks as the way a census was conducted in the Roman times, where the Census Bureau would dispatch its people to each city in the empire. Each census taker in each city would be tasked to count the number of people in that city and then return their results to the capital city. There, the results from each city would be reduced to a single count, sum of all cities, to determine the overall population of the empire. This mapping of people to cities in parallel and then combining the results, reducing, is much more efficient than sending a single person to count every person in the empire in a serial fashion. How MapReduce works. Let's explore a little bit further two components of the MapReduce program, the mapper and the reducer. This will be a very high-level discussion, and then we'll see the details when we actually use Java or Python later on. So here is a pseudocode for a mapper. Each mapper will execute each line of the input file until no more lines remain. Once the line is read, the line is then tokenized using a function called tokenizer. We can split it by a comma, we can split it by space, we can split it by tab, based on what we know about the input file. Once these tokens are created, then we assign some variables to these tokens. For example, we're going to capture the ticker of the stock and the price, the trade price. So, assuming that the ticker is the first field in the input line, then the trade price is the third token. We can assign ticker equal to token 0, trade price equal to token 2. And then we are going to send to the reducer the values, okay? The values are sent also in a key value form, okay? So the input is in the key value. Actually, the key is the byte offset and the value is the line. The output is the key value, and the key value is the values that we have captured throughout the processing of the mapper. So this is the mapper. Let's go to the reducer. Now the reducer also captures a key value and emits a key value, okay? For example, in this case, the reducer is going to receive the ticker and the trade price from the mapper, all right? That's the key and the value. Now the reducer is going to, for each key, is going to calculate the maximum price, okay? So we start the maximum price of 0, and then we are going to go to a loop for each key and make sure that we always keep the maximum price using so if value is more than maximum price, then the maximum price becomes the value, right? Once there is no more of the specific key, the reducer will emit the key and the maximum price. So let's explain now what specifically happens. Assume that the input file is listed in the very left corner here, okay? So we have the ticker, the day of the trade, and the price, okay? So you can see, for example, CAH is repeated multiple times throughout this file, and we want to find the maximum price of that stock. So we're going to split this file into multiple files that can be processed very quickly. Let's say we get the first few records in one file. So for the purpose of this illustration, we are going to have three smaller files. And then the mapping is going to read each file and is going to emit the price of the file, right? We read the first token and the third token, and we send out to the second stage, which is the reducer stage, we send out the file. So actually there is a shuffling process that happens between mapping and reducing, where each key is associated with a list of values, okay? So these will come in this order to the reducer, and the reducer will take each of them, make the comparison, and keep always the maximum price, right? For BAC 26, 25, 25, the result of reducer is going to be BAC 26. And once the maximum price is calculated, then the reducer will emit the final results and store them back into the cluster. This is a general concept of MapReduce, and in the next tutorial, I'll show you how to run a MapReduce job. We are going to have two parts, Part A and Part B. In Part A, we are going to run a MapReduce job with Java. In Part B, we are going to run a MapReduce job with Python. So you can choose one of these directions based on the language that you are more familiar with. If you are not familiar with either Java or Python, I would suggest going with Python because it's much simpler, much more straightforward. But if you use Java, I think you will really enjoy the Java part because you can see the potential of using Java for MapReduce tasks. I'll see you in the next video. Thank you. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.